All right, let me just draw another one. I think I'm most. All right, so there's 200 students that took that SAT test. The average score is 1,100. That's going to be in my middle because average, remember, average is the same word as the mean. It's a synonym for the mean. So whenever you see the word average and mean, it means the same thing. So let me redraw a nice curve. Again, the more curves you draw, the better you're going to get on it. So the mean was 1,100. Go and draw a line right in the middle. 1,100. Okay. The standard deviation was 210.
Wait, you said 1,100?
Right, it's the mean, huh?
Yeah, you had 1,000.
So wait. Coffee time. I need some more coffee. All right, so the first standard deviation, remember, is the point where the curve changes. So right here and right here. Let me draw a line. That's the first standard deviation below, first standard deviation above, second above, second below, third above, third below. We're rocking and rolling. They should be the same distance here, so I kind of messed up here. Let me move this a little bit here. You want to make sure that this is all the same. From here to here, the same as it, because this is the same standard deviation. The intervals, the increments here. Okay? You want to make sure they're the same distance, even though mine is kind of messed up already. So it should be a little bit more like that. So it kind of evens out. These should all be the same distance here. These intervals. All right. What would one standard deviation below be here? What would be this value here? Thinking of yesterday's notes. What would this value be? One below. How would I figure that out? Now Ortiz, you gotta help me out. How would I figure out this value? Well, let's look at yesterday's notes. Let's watch this. Look at, here's your mean, Ortiz. Here's your mean. This is one sigma below right here. 2 sigma belows, 3 sigma. So the question is, what's my sigma value? What is sigma here? You guys remember what sigma means? Right, the standard deviation. So sigma means the standard deviation is going to be 210. So I'm going to take 1,100 and subtract 210 from it. So watch this. Subtract 210. This will be 890. Want to put that on your curve?
It'll be negative 890?
No, I took 210 and subtracted from there. That would be the score of 890. Some students scored 890 on the SAT. We don't know who yet. How about the second 2 standard deviations below 1,100? So I'm going to take 890 minus 210. 680. 3 standard deviations below. 470. 1 standard deviation above. It's going to be 1310. 2 standard deviations above. 1520. And then 1730. Okay. So the question is now, let's see what the mission is. How many students scored between 890 and 1,100? So I'm gonna get my crayon. Let me color in between 890 and 1,100. So the question is asking, how many students scored in between here? So what I'm coloring right here. How would I figure that out? Close. Let's look at the rule from yesterday. So that's 50%. Let me look at the 68, 95, 99.7 rule. Let's see. Look at this rule here. Look at one standard deviation below and one standard deviation above. Look at 68% of the data is all in there. So, right, look at. So, we know from here to there, look at, it's 68% of the data. You with me, Ortiz?
Yeah.
And so that's going to be half of 68. So we can say 34%. 34% of test takers or students scored between 890 and 1,100. Okay? But isn't the question, look at the question a little more specific. If I zoom in on the question, look what the question is asking. The question is, look, how many students scored? We just answered the percent. That's the percent of students who scored. Now if I ask, okay, how many actual students actually scored that? What was the number of students? Don't give it to me in percent. How many students actually scored between 890 and 110? How would you figure out exactly how many students scored between 898 and 110? Or 1,100? We got the percent. But I don't. Let's say I don't want the percent. And the question is really asking. It's not asking percent. It's actually how many. What was the number of students that actually did score between that? We got the percent. So how would I figure out how many now? What do you guys think? That makes sense, Ricky?
Yeah.
So 200 is a total. That's the students. 34% means 34 out of 100. So cross multiply. 200 times 34 is 6,800. X times 100, 100x divided by 100. So this would be 68 students. So 68 students is actually the 34%. This is the actual amount of students here. Good. Let's go on to number 2 real quick. So number 2. There we go. Have some space in your warm-up. What percent of students scored between let's see, 1,100. Actually, about between 1,100 and 1,520, yeah. 1,100 and 1,520. Want to write that in your warm-up? Same paper. Okay, so let's see here. So the question is now, let me color in the graph here. in blue. This area, between 1,100 and 1,520, what percent is this going to be, is the question. What percent of the students is that? What do you guys think? 47.5? How'd you get that, Mr. Pinello? Right. Right, so from the mean, 2 sigmas below, that's 2 standard deviations below, 2 standard deviations above, comprises 95% of the data. Ortiz, you with me? So 2 below, 2 above is 95% of the data. So all that's in blue is half of 95. That makes sense? So you took 95 divided by 2. And what you get again, Mr. Pinello? What you get again when you divide 95 by 2?
Oh.
47.5% of students scored between 1,100 and 1,520. Very nice. So question 3 on our warm-up. Question 3 is, what percent of the class scored between 680 and 890? 680 and 890. So copy that down. So I know that, let's see, 680 and 890. So 680 is 2 standard deviations below. Here's 680. And 890 is 1 standard deviation below. So I'm really asking, the question is really what percent of the class is this right here, right? It's a little trickier. 23.75%. Man, let's see. What was your thinking? Half of a half. Okay, let's see. So, you know from the mean to the second standard deviation below is 47.5, huh? Now, so this right here, let me color 47.5. So all this is 47.5. You're telling me that this is half of that? Look at what's in green. What's in green? Does what's in green look half of everything that's in blue? It's smaller than half, huh? So it's not going to be half. This part is not half of 47.5. We know all this right here, everything right here is 47.5, but what's in green is not exactly half of all that. It's a part of the curve. This area under the curve is less than half. So it's not as easy as just taking 47.5 and chopping it in half. It's not the same. You guys see the problem here? You guys appreciate the problem. So I'm up at 2 stamps now, 2 stamps extra. How can we figure this out? So I want to know what percent of the class is this. stems. The empirical rule and the 68, 95, 99.7 rule mean the same thing. So we're really looking for this part, huh? Watch. If I look at it's between the second and first below. So we're looking for this sliver right here. We know 95% of the data is 2 standard deviations, 68 1 standard deviation. 3 is almost all, look at it, it's almost 99.7% of the data. Almost all of the data is in between 3 standard deviations. So how can I figure out this sliver, the percentage? That's the question. Free assignment pass. I'm waiting on Pinello. I think Pinello's up to something. So we know that we're going to the second standard deviation. Look at, so from the mean down to the second, we're stopping at the second standard deviation. That's where the data, look at right here. Here's 680, the second standard deviation. We know the data that we're interested in here is between the second and the first. So if I could just figure out what percent of this, that sliver, in between the first and the second, we're in business. So what I want to do then is from here to here, that percent of the data is how much? Oh yeah, no, not from the first, but from here to here is how much percent? What percent of the data is that? Ortiz? From here to here. 2 above, 2 below. What percent of the data is from here to here? 95. So watch this. 95% of the data is in between the second above and second below. We agree to that. That's clear with the arrow. Look at it. Goes from here to there. What if we were to take the 95 and subtract the turquoise? If I take 95 and subtract 68, I'll get rid of this percent right here in the middle. So I'll be getting rid of all this. If I took away 68. So let's see, 95 minus 68, let me see what I get there, watch. 95 minus 68. Look at this. This is 27%. So what would this 27% represent, Pinello? The 2 what? What's the color? What color? Right. You see that? I took 95. That's everything here, and I took away from it the turquoise.
Right, because they said you can do the left of it, right?
Say again? Well, you see how I took away the 68%, what's turquoise? And the 27% then is what's left over, which is the blue. This and that. If I add up this blue and this blue, it's going to be 27%. But I only want one of them, huh? So if I take 27 and chop it in half now, see 27 divided by 2? It's going to be 13.5. So right here is 13.5%. And this is going to be 13.5%. The blue only. And that's exactly what we're interested in, huh? Okay. So the students who scored between 680 and 890, 13.5% of the students. So let's see, for example, so 13.5% of students. What do you guys think? Last one. It's all logic. So to recap. So let me do my game plan again. I took 95% of the data, subtracted 68, got 27. That means this blue and this blue make up 27%. I chopped it in half. I got 13.5%. So far, so good. Last question. Erase this. So question 4, last one of the day. What percent of students scored between 1520 and 1730? All right. So 1520 and 1730, that's all this right here. That's the question. What percent is that part of the data between the second and third standard deviation? I'll give you a hint. It's similar to the way we solved for the previous number 3. So we're interested in right there. In other words, what percent would be between, I'll highlight it in red. The question is, what percent is this in red? That's the question. Between the second and third above. What's the first thing you did? Spinello.
Red, 99.7.
Right, so look at, so from the third standard deviation below to the third above is 99.7% of the data. And what you subtract from that? Right, so all this, he subtracted all this data. All this data in black is 95, so you subtract 95 from it. We're going to get what's left over that's in red. The red area, which is going to be 4 points. Let's see, that's going to be what? Yeah, 4.7%. So the red, both reds add up to be 4.7%, but we only want one of them. So you chop it in half, and you got 2.35%. That's how much scored between 1520 and 1730. Excellent work. Very nice. I'm impressed. I'm giving you the rest of the 20 minutes to work on either 42, 40, 41, or 43. Use it wisely. Let's get busy.